Located in Wynn Commons, the Design Innovation Lab holds many machines for UW-Madison College of Engineering students to use. The machine we'll be focusing on is down in the shop of the Design Lab, the CNC router.
Okay, so what is a CNC router and what does it do? The CNC router is a commonly used computer control machine used to cut, carve, and engrave many material, such as wood, plastic, and foam. This machine is extremely useful and versatile for completing projects that requires extensive cutting. However, an extraordinary amount of dust is emitted to the point of covering up the entire room, including the machine, floor, and people, as shown in the next clip. This buildup of dust presents many health and safety risks, including respiratory and skin issue, a major slipping risk, and even a fire hazard, as shown by the aftermath of the test runs.
As a result, our client, Matt Mavie, tasked our group with coming up with a solution to this problem by designing a containment system for the dust in order to minimize health and safety risks. Now, let's discuss the two solutions we devised. Following research done on CNC routers and other existing dust containment systems, our group came up with three potential designs. Based on factors such as efficiency, safety, and manufacturability, we were able to narrow down our solution to a combination of two designs, the air nozzle and the contractible bristle dust shoe. The current dust shoe bristles are too short to stop dust from spreading during cutting, and they splay out and leave large gaps when they make contact with the workpiece surface when cutting material over an inch thick. This allows dust to escape before the vacuum can absorb it, especially when cutting thicker materials. Our contractible bristle dust shoe design aims to address both of these issues. It has pins instead of bristles, and these pins push upwards in their slots instead of splaying out when cutting thicker material, maintaining a barrier that prevents dust from escaping. The pins are also about an inch longer than the current bristles, which helps reduce the spread of dust overall. The air nozzle prevents the accumulation of dust by blowing pressurized air down towards the end mill, forcing the dust upwards into the vacuum chute. In this design, pressurized air is fed through pneumatic tubing and to the air nozzle's airflow regulator. The air nozzle itself is then inserted into the dust chute and pointed towards the end mill. We hope that this combined design would be the most efficient way to minimize both the spread and accumulation of dust from the CNC router. To fabricate the contractible bristles, we made the pin model on Onshape and then 3D printed 105 pins using TPU filament, a flexible and inexpensive material. The dust shoe itself consisted of two separate components, the frame and the pin rack, that were cut out of HDF using the laser cutter and then glued together. After gluing 6 magnets to the top of the shoe so it could securely attach to the router, all of the pins were inserted into the pinholes of the pin rack, completing the contractible bristle dust shoe. The fabrication process for the air nozzle was much more straightforward. It was made primarily from pre-existing parts that only needed to be assembled. This system needed a source of pressurized air as well, so we attached an air splitter onto the router's existing connection to the airline to split the flow of air. To test the dust containment capabilities of our design, we placed note cards on the router baseboard, 6, 12, and 18 inches away from an NDF workpiece. Cut the workpiece, and then weighed the note cards to determine how much dust accumulated at each distance. We first determined the optimal PSI for the air nozzle, then tested our combined design. The testing data showed that our design reduced dust accumulation by over 70% and reduced the spread of dust overall. Thus, our design has proven to be effective at reducing the spread and accumulation of dust produced by the CNC router during the cutting process.